next one. So, ordinary differential equation, or ODE for short. By the way, that's not even the full name of it. The full proper name should be first order ordinary differential, no sorry, that's not even it. First order homogeneous ordinary differential equations, or ODE for short. So what are ODEs? Well, ODE is any equation that has the derivative inside of it. Hey, come on, I want to start there, come on. So what is an ODE? An ODE is any equation that has the derivative inside of it. So here is one simple example of an ODE. dy dx minus x squared equals 0. That's a simple example of an ODE. It has a derivative inside the equation, and that really makes it an ODE. So can we solve this? Can we find y? And the answer is, in this case, yes, it's not so difficult, because we get dy dx equals x squared. Now, how do I cancel a derivative? How do I cancel a derivative? Antiderivative. So if I put an antiderivative on both sides, I get the result y must equal x squared plus c. So we can check if this is right. What's the derivative of y here? Oh, sorry, not x squared. What am I saying? Apologies. X cubed over 3. So we can check this here. What's the derivative of x cubed over 3? What's the derivative? What is it? No, be careful. Bring the 3 down. Yeah, it'll be x squared. Bring the 3 down. Derivative. Bring the 3 down. They cancel, and then take 1 from the power, leaving you with 2. Derivative, just derivative of this. So the derivative of this is x squared. So does the derivative of this minus x squared equal 0? It does. I'm just trying to say that if you substitute that back in here, you'll see that it does equal 0. So it is a solution. The only problem is, I don't know what the c is. But that's okay, because in the question, they'll give you some extra information if you want to find the c. So for example, if I then tell you that y0 is equal to 3, that means I know when x is 0, my y should be 3. So I know I should get 3 when I put x as 0. Therefore, what must the c equal? Must equal 3. So in fact, this is the full solution. Y equals 1/3 x cubed plus 3. Yes? We're going to look at 2 methods today to solving ODEs. The first method doesn't really happen in the exam because it's a little too easy. And that's the method I just did there.
That's easy?
Yeah. Let me show you another one. So for example, if I said dy dx minus cos x equals 0, I want to solve this, I would get dy dx equals cos x. So then if I integrate, what do I get for y? What's the antiderivative of cos x? If the derivative is cos x, then what was the y? Sin x plus c. Okay? So this method is called just the direct method. But this method only works when you can write your equation in this form: dy dx equals some function of x, like here. Because once you've done that, all you need to do is integrate, and it's finished then. So direct method works when you got this situation, which is exactly what was here. So that's the direct method. And one more example of direct method. So for example now, if I said dy dx equals x, well, what would be the solution here? What would it be? Who can see? Y equals, yeah, x squared over 2 plus c. Now just for some vocabulary, okay? If I don't give you enough information, that is, if I don't give you a point so that you can find the c, we actually call this the general solution. So don't be put off by this word in the exam. If they say find the general solution, that just means find the solution, and it's not necessary to find the c. In fact, you couldn't find the c because they wouldn't have told you a point. Okay, so are we happy with the direct method? Okay, next method now. So the next method will be called separation of variables, separation method, or as I'll just call it in the exam, or when I'm doing the answer, the SOV method, separation of variables. Okay? You have a good talent, Sayun, of coming in at the last moment. Now, when do you need this situation? You need this situation when you have a mixture of x and y. So, for example, if I said something, let's say, if I said something like this, dy dx minus y equals 0. This is quite different now, because if you actually look at it, there's no function of x. There's just a y. And if you try to use the direct method, you come across a huge problem. Although you can integrate the left, you get y, you can't actually integrate the right. Now the reason for that, so if you look here, we have learned how to do implicit differentiation. So when you differentiate something with a y, it's like with an x, but then you multiply the answer by dy dx. And it almost feels like we should be doing implicit integration, because on the right you want to integrate your y, and then you might think, well, don't I integrate it and then maybe I divide by dy dx or something like this? And unfortunately not. It doesn't work like that. So your implicit differentiation is only for differentiation. There's no such thing as implicit integration. So here's the problem. What do we do when we get to this? Well, this is where the different method comes in, the separation of variables. What you do is you look at your dy dx and you take the dx up to the right. So the first thing you do is you separate a dy side and a dx side. And this one here is called the y side, and then this one here I call it the x side. So all my y's must be on the left and all my x's must be on the right. So therefore I need to divide my y. So I get 1 over y dy equals dx. Now when it's separated like this, you have a situation whereby when you integrate you can do it, because this left hand side is dy just like du or dx. So it's actually just like an x integration. Likewise on the right. So what is, pretend it was 1 over x dx. What would be the antiderivative of that? Come on. Wake up time. Wake up. Are you all sleepy after your lunch? Did you all have big lunches? It's raining. I'm sleepy. Tell me what the left here would be. Log. Yes, log y. And on the right, very good, x plus c. Please note, I only need the c on one side. It's not necessary to put on both. But that's not quite finished, because I'm not looking for log y, I'm looking for y. So how do I cancel a log? With an e, with an exponential. So this, in fact, is my answer. And again, if I give you a point, you could find the c. So let's say, for example, I say when x is 0, y is 1. I can use this to get my c. Pretend it was given to me. So you might think, oh, well, just put it back into here. And that's fine. But it's a little bit easier, and it's perfectly fine if you want to put it back into this equation. Because it's easier to get the c from this. So you have log 1 equals 0 plus c. So therefore, what would c equal here? Which is? 0. So in fact, this is the answer. Y equals EX is the full answer.
Where did we get 0?
It's given to you. I'll write that underneath, sorry, given. Okay, another example now. Let's say dy dx minus xy equals 0. So first thing I'll do is I'll take that xy to the right. And I have no choice here. The left must be the y side and... Say again?
That's a new example.
Oh yeah, new example. I have no choice here. The left must be the y side and the right must be the x side. Therefore, my y here is on the wrong side. I should bring it to the left. 1 over y dy equals x dx. Now I can integrate. What do I get on the left? Log y. And on the right here? A half x squared plus c. So I get y equals e power a half x squared plus c. Now I also tell you that y0 should equal 1. So if I sub that back in, I can get my c, just like what you did in week 1, semester 1. Log 1 should equal 0 plus c. So therefore, once again, c equals 0. So now my answer is y equals e to the power a half x squared.
I don't understand.
Dot dot dot. Yes, which part?
Like, from where did you get the half x?
It's just increase the power by 1, divide by the new power. What?
Why did you make y 0 equals 2?
Like I said, it's given to you. It's like people don't listen to me. Come on, Curdy, wake up. You look exhausted. Why are you so tired? You're worrying about your car, isn't it? Yeah. You know. You're thinking, I hope it's okay. Yeah. Is it in the garage? Is it being fixed now? No? Okay. Now, that is how to solve ODEs. There's one small thing left to do here, and that is sometimes, although quite rare, Brendan, stop checking your hair in the phone and come on and focus. Yes, please, come on, focus here. Right, okay, so the last thing to do is sometimes you can be asked in the exam, although it doesn't happen too much, to verify. And what I mean by verify is they'll give you an equation and they'll give you an answer and you have to check that the answer is right. Now, it always will be right. You just need to show that it's right, that you need to check that it's right. So the equation looks difficult, but you don't have to solve it. They have solved it. So here's an example. Verify that y equals ex is a solution to this equation. 2 dy dx minus dy dx minus y equals 0. So the way to verify this is first you write down what y equals, then you write down what the first derivative equals. What will that be here? Ex also. And then you write down what the next one will equal. It'll be ex. So this is kind of an easy one because they're all ex. I mean, it's usually going to be something like this anyways. It might be e3x or whatever. Then what you do is you put these three results back into this and check that it's equal to 0. So you get 2ex minus ex minus ex. That equals 2ex minus 2ex, which of course is 0. So yeah, y equals ex is a solution to that equation. Because when you use y equals ex, it does equal 0. Okay.